These refractory materials will be submerged in a regolith melt with both anorthositic and basaltic compositions at temperatures of around 1300 degrees Celsius for durations of roughly 1 hour. The steel housing was custom designed in-house at the Colorado School of Mines.
This experiment tested whether boron nitride reacted with silicon carbide or the molybdenum when coated, and also helping if it had any refractory longevity. So like in dwell test 1, the rods were cast into the steel housing and then submerged into a molten regolith simulant for 1 hour. After removing it, the team observed that all 4 rods remained within the housing and appeared to maintain most of their section. The rods were then left to cool and then were set aside for post-mortem microstructural characterization. And then the remaining molten regolith simulant was then poured into the crucibles and left to cool in ambient room temperatures.
This was accomplished by outfitting our original steel housing with bearings and changeover and sprockets. These rods could be rotated either manually by hand or with an offset motor as needed. The dynamic test lasted only 5 minutes. However, that short test showed immediate results. Once dwell testing was complete, the regolith melt was poured across 2 sets of matching silicon carbide and molybdenum tiles. Similar to the dynamic test, 1 set of these tiles was coated with boron nitride. The pour test was conducted in order to measure the flow rate of molten material across each refractory media, with thermocouples tracking the heat profile of the refractory tiles, and then the tiles then being examined for damage once testing was complete.